Welcome.
To the joy of coding.
Hello, and welcome to episode 106 of The Joy of Coding. My name is Mike Conley. I am sorry that my camera is a little zoomed out, a little haphazard today. Just trying to get a lot done, and unfortunately I didn't get to finish setting up in time. So that's why I'm a little bit late. I'm about 2 minutes late, and so I'm a little frazzled. But hey, that's the joy of coding. Hi. Good to see you. I'm Mike Conley. We're going to be hacking on some Firefox stuff today. Let me share my screen with you. Whoop. There we go. And my Evernote. So, today is July 19th. A quick reminder that no plan survives breakfast. Things could go horribly wrong during this live hacking session. That's totally okay. That's actually kind of the point. I'm trying to capture the real, raw experience of hacking on an open source project or a large code base. So nothing that you're seeing has been pre-planned or really thought through. It's just me hacking on bugs and thinking aloud as I go. So quick check, is everything working? Yeah, you can hear me. Dropping frames? No. And can you hear sounds? Yes, you can. Wonderful. One last reminder before I remove this is that there is an episode guide for the joy of coding. You may be interested in contributing to it. Unfortunately, there haven't been too many contributions, but who knows? Maybe this will eventually grow. This late blooming seed might grow. The episode guide is entirely run by viewers of this show. Feel free to send pull requests. I manage it, but I will happily accept your pull requests, even if they're not. Even if they're just your own personal notes or additions or links that you think are handy for a particular episode, I'm happy to take them. So go ahead and send pull requests. I'm very liberal about my accepting of pull requests for that repository. Okay, finally, I want to update you about something. Last episode, we were working on this bug to ensure all page loader tests written with for Talos can return Gecko profiles and run with the Gecko profiler. That landed yesterday, so that's good. And the second thing I want to update you about is actually our location bar test. There is a couple of episodes ago we were working on a better location bar test, and I got it to work. It was like kind of failing intermittently, and I got it to work. And the way I got it to work, well, first of all, remember how we had this big stack of, or big list of stacks, is I simplified things by saying how many times, like you call out specifically how many times a particular stack might show up. And that helped sort of crunch the numbers down a little bit, or crunch the number of stacks. And then finally, the thing I had to do was, what did I have to do? I had to add dirty frame function calls inside both invalidate and on results added. Originally, I was doing it inside something called set timeout. I don't actually need to do that. I need to do that inside invalidate and on results added. And that is how I was able to fix this and make it sort of run reliably. So that has some review comments that I still need to deal with, but is otherwise ready to go, except that it's depending on a bug that I'm hoping to land today. But I want to work on something else today, actually. But first, let me put a link to that bug in the notes. Oh, I should mention what you're looking at right now. This Evernote is actually available to you. If you are watching this on Air Mozilla, then go to the additional links section down below, and you'll be able to find a. Hang on, and now I should update this. This is landed in Central, and it needs to be exported to my bug notes repository. And the bug is now closed, so I can now close this. Whoop, closed. So you just saw how I track bugs. Yeah, this. What was I just saying? Yeah, this agenda that we're looking at right here is available to you with all the links, etc., etc. And if you scroll down to the additional links section, you can find a link to it. There's also a link to a form that you can fill out to give me a rating on this episode. I love to hear ratings. I love to hear how people are liking or not liking Joy of Coding, so I can get feedback to help improve things. I read every single review that comes in, every single piece of feedback. So do rate this episode and let me know what you thought. Here's the link. And it's in the agenda. Now, if you're watching this on Facebook, I actually haven't commented in Facebook with the link yet. So I'm actually going to do that right now. I'm going to do it off screen so I don't share personal Facebooky things that my friends and family have posted to the whole world. But let me just put a link to the agenda and the rate this episode. I'm sorry I forgot to do this on Facebook. Hold up. It's coming. So here's the link to the agenda. Just put that in here. Comment. Agenda. And then rate this episode. That's this link. And comment. Now, why is my machine running so... Oh, you know what? Crash Plan's running. I'm going to pause Crash Plan for a little while. Is that why I'm so slow? OBS is also... Holy smokes, OBS. What are you doing? OBS, Crash Plan, nightly web content's being a little bit of a pain. That's probably Facebook. But at least I can probably shut down Crash Plan for a little bit. Okay, so I've just commented in the Facebook post with the links to the agenda and rate this episode. And finally, if you're watching this on YouTube, just check the video description. Oh, and finally, if you're watching this on Twitch, I'm about to drop the link into the Twitch chat. Bam! There's the Evernote. And for the rate this episode link, it's going into the Twitch chat right now. There it is. Okay. So, what are we working on today? Well, there is a feature that just got turned on in Nightly yesterday, actually. You may or may not be already familiar with this project. It's called Activity Stream. What it is it's sort of a reinvention of the new tab page, and this is it. I mean, I know this looks a lot like the new tab page that you may already know and be familiar with, but there's a lot different under the hood. And one of the things that's different about this is that this page now runs in the content process as opposed to the parent process. One of the things that the old About New Tab page did was it ran with a bunch of elevated privileges, and we don't like to do that, especially in the because it ran in the parent process. That meant that any thinking or preloading that it does affects the parent process, can jank the parent process. So the activity stream replacement for About New Tab runs in the content process, which is good. But there is a problem, and the problem is that it was enabled yesterday, and one of the tests that is that's run for every or mostly every commit that goes in is something called Are We Slim Yet? The Are We Slim Yet tests. And the Are We Slim Yet tests, if we read them here, track memory usage, builds on the website, uses some infrastructure as about memory to measure memory usage. So Are We Slim Yet is now a built-in test. It used to be a web page. Like if you used to go to Are We Slim Yet, this is like the old archival data from 2016, and this is no longer up to date. What is up to date is the stuff in Perf here. So if I look at, say, Mozilla Central, Are We Slim Yet on Linux 64 for the past 90 or 60 days, slim, or wait, yeah, I'll just look at it all. Oh, subtests, yeah. That might actually be more useful, is to look at the individual subtests. But let's take a look. There's this little bump right here, and I'm pretty sure that's when Activity Stream was enabled. Hold on, let me zoom out a little bit. I'll make it easier to read. So there's this bump yesterday, July 18th. Now, that was on Mozilla Central. I'm gonna get rid of these graphs. I'm gonna look at Autoland instead, because that's where it was turned on. And we're gonna look at Are We Slim Yet? And we're gonna look at all of these last 60 days. So here's the bump. It's already been highlighted by people. Now there's a very strong bump in resident memory. resident memory being used. So that's what maybe we're going to focus our attention on. Let me pump up the font size here. You can see that better. Now, resident memory is sort of a summary of a bunch of subtests in Are We Slim Yet? So we're going to include the subtests. We're going to look at resident memory and look at each of the subtests, because Are We Slim Yet actually it has these different checkpoints on that where it measures memory. And one of these checkpoints might be where the problem is. So I'm going to get rid of that first measurement. I'm actually going to get rid of, I'm going to hide most of these measurements. Let's just hide all of them to start. So here's one that's interesting. Resident memory on closed, that's one of the checkpoints. Tabs closed, that has regressed quite a bit. That's after 30 seconds. It's also regressed quite a bit. And after a forced GC is regressed quite a bit. Fresh startup, everything looks fine, no change. After 30 seconds, no change. After tabs open, let me zoom, I'm in the wrong level here. Everything looks okay after the tabs have opened. Resident memory after 30 seconds after the tabs have opened, everything's okay. And after a forced GC, everything's okay. So it's really, if I close all of these ones, it's just the tabs closed ones that we're interested in. Boom, boom, boom. So when we close, then after 30 seconds, and then after a forced GC, there's still a bit of a bump in the amount of memory being consumed by the browser. And I'm not super surprised, because one of the things that that running in the so there are some things that we do, some perceived performance optimizations that we do, specially with the new tab, because the new tab is something that we want to show very quick. We want it to show immediately. Whenever you ask for it, we want it to be there and in your face. Excuse me. And so whenever you click on a new tab, like that showed up pretty fast. But one of the things that we do, we have this hack that we do, I'd call it, where it's actually been preloaded in the background. All of the calculations to lay it out have already been done. And then when you open new tab, we just show it. We finally just paint it. But all the calculations for it have occurred in the background. And that's called preloading. Now we also have this thing called the process pre-allocator. That is, oh, hang on a second, check this out. There's this little dip right here in Autoland. What is that? Oh, I think they backed out. They briefly backed out enabling activity stream. Okay. So this is the patch that causes the regression. It turns on a thing. So a bunch of code then starts to run. And this preloading is, I think, where we're being bitten. And I want to investigate that today. So let's do that. I was able to run the Are We Slim Yet test locally, or not really locally, but on beast mode, my Linux box that I have by my desk. Let me sign into beast mode. And yeah, it looks like it's still running. I'd started it before, and it's just like hanging out. Now it's running it all over again. So I'm interested in trying to reproduce this. It's wacky how I can't click. What is going on there? Preferences, input. Can I click? Normally when I run this, I can click. All right, I'm going to quit the current run because it was doing it a couple of iterations. Also, it is boiling in here. We're going to look at the code for the test. I was already looking at this today. Memory usage. And the part that I think that's important, so this is the code that runs the Are We Slim Yet test. The code that I think is important is actually here. So after switching between all the tabs, memory's been the same. Then we close all the tabs, and then we navigate to about blank. And then we say signal user active. Signal to the browser that the user is active. The browser thinks the user is active because the user activity is detected by looking at key and mouse events. I don't know why we do this. Instead, we manually cause some inconsequential activity to make the browser think the user is active. Then when we sleep to allow things to settle, the browser will see the user becoming inactive and trigger appropriate GCs as would have happened in real use. Oh, okay. Signaling user active, then tabs close, wait some settling. So between this checkpoint, so whenever we do create checkpoint, that's when we like collect memory reports. So these three memory reports for checkpoint tab close settles, and tab close force GC are the ones that are we're detecting a regression on. And that's very interesting. Now there's a GitHub issue. Activity stream regression. Where is it? Where is it? Where is it? Where is it? Here it is. Moving back to the main process is one thing that Mardak is suggesting that we do. I'm less keen to do that. He is able to run it not on his Mac but on a Linux VM. Slimia entities for iterations 1. Let's do that. Let's do entities for iterations 1. We're going to see what this looks like when we do that. And hold on, you can't see the bottom here where I'm typing. So I'm going to say, hey, beast mode. And this is on current Mozilla Central. So this has the regression. I'm going to say mock are we slim yet test entities for iterations 1. Oh, that's interesting. And then he like pretty prints the JSON. Oh, hang on. I gotta run that on display 1. So here's display 1. We can see the browser now getting started. It is boiling in here. So this is part of the testing. Cake Rex, I'd never even heard of that. 3, some Baidu page. These are all from the TP5 set, which is a snapshot of the internet taken a long time ago. So for 4 tabs now open. So the tabs open, snapshots taken. Great. Come on, what are we waiting for? Oh, it does GC now. It closes them, and it's here. Turning on the web servers, and it's done. So here's the result. And it created these about memory reports, which are good. We can actually examine those if I can somehow get them to a Firefox browser. After we force GC. So here's what my suspicion is: if we examine this I'll be able to load, if I can get it to run, I can maybe load the, oh, sorry, not display 0, wrong display. Display 1. What the? Where's the menu button? This is all wacky. Alright, anyway, about memory. We're gonna load. I'm also gonna up the yeah. Where are we? We're going to try and load default tests. Default tests. Are we slim yet? Results. Memory report tab closed. Force GC. I've just told the activity stream team that I'm live hacking on this stuff. They might want to follow along. Let me just send them. Yeah. Whoop! Inception. If you folks want to follow along. So here's the memory report. We've got the main, so that's after we've closed everything. The main process is still here. We have one content process, and that's it. And the content process, it would not surprise me if it was pointed at about new tab. Yeah, it looks like it. And about blank. So it's actually interesting because after all the tabs have closed, there isn't like another process hanging around with the latest stuff. It's just like about new tab is loaded and hanging around. which isn't surprising because it's just kind of hanging out there in the background. And where is that memory being used? Well, one thing we can do is we can save this. We're going to save this memory report. Or it'd be great if I could like bring it out here to my Windows machine. So what I'm going to do is I'm going to quit. I'm going to transfer this memory report to my OS X machine. And the one I want is the after GC one. Because like that's the last one. Tabs closed. Force GC. That's the last one, right? Tabs closed, force GC. Yeah, it's the last one. Tabs closed, force GC. So now I'm going to try and get that onto my OS X machine. I'm going to SSH into my virtual machine and pull it out. So I'm going to create a directory here. Always slimyet bug. Let's pump up the font a little so you can see it, and then drag up the bottom so you can see it. Hold up. Okay, so what is the IP address of my virtual machine here? Oh, it's beast mode. Oh, okay. It's beast mode. I can work with that. Beast mode, and we're going to take that directory. What was it? Home / that, and then tabs closed force GC. Oh, come on, copy. And we're going to copy to current directory. Bam, there we go. Okay, now I'm going to rename this memory report tabs closed force GC dash bad.json.gz. So that's the one that has the leak in it. So now I'm going to, on beast mode, run that whole exercise again, but I'm going to back out the activity stream patch, which was this one, right? Yes. Yeah, okay. So we're going to back out that. And I'll give it a better name, disable activity stream. Okay, and now I'm going to build. Then we're going to run it again, and I'm going to use a tool that I've never actually used before, but if you look, About Memory has this like load and diff tool. So what I can do is I can load the old one, or load the good case, and then load the bad case and do a diff between the two. And that might, I mean, there's going to be obvious, there's going to be the obvious problem of like the you know, it's just about new tab, but it's like what parts of about new tab are hurting us here. So we're going to run this again, and let's see what happens. So we're loading it up. Are we slim yet? How's the stream going? Are you still seeing me? Yes. Am I dropping packets? No. That's good. So, Are We Slim Yet does this like a lot of this just sitting around waiting for GCs to occur and stuff, which is kind of annoying. Makes me impatient.
What happened? What happened? Hey, what happened?
Okie dokie.
Mamma mia!
It's me, Me, Mario.
Alright. Actually, if I play that entire Jeopardy song, I think YouTube gets mad at me. They're like, oh, that's a copyrighted song, and then they get mad at me. Okay, that's the last test, or the last tab, I should say. So now, if you can see in the background here, it's finished storing the tab open checkpoint, and then it's going to wait a bunch of time, and it's going to close all this stuff. Okay, so now we've got the tab closed memory port created. That's good. It's going to wait a while. Come on, come on, come on, come on. I think it's like waiting a bunch of time to be settled, and then it's going to do a GC, and then it's going to write out the report again, and then we're done. Okay. So now I'm going to take the same, it's got the same name. I'm going to SCP that report here. I'm actually going to do 2 steps in one. I'm going to rename this to, instead of -0, good. And then, there we go. So now I should be able to load from actually projects. There should be an Are We Slim Yet bug. We're going to load good. Here's good. And then we're going to load and diff with bad. Oh. Load and diff actually wants 2. Okay, so load and diff. I will do good and then bad. So the difference is in the web content process, unsurprisingly. And there's some in the main process as well, apparently. But let's collapse all this stuff, and we'll go through it bit by bit. Okay. So we're consuming about 8 megs more in the content process that exists. There's no like mysterious heap, like dark matter detector requiring heap, mysterious heap dark matter. That's good. Oh, and apparently the activity stream people are watching now. That's cool. Hello, activity stream team. So what I've done, just to catch you up, is I've run the test locally, the Are We Slim Yet test locally, or rather on my Linux box near my machine, and I've taken 2 memory reports. I've looked at the graph. So this is the Are We Slim Yet graph, and most of I might be telling you stuff you already know, but everything about Are We Slim Yet, the 2 points, the 2 revisions are the same except for this part of the test, which is how much memory we're consuming after we've closed all of the tabs and we just have an about blank loaded. And looking at the most recent central, I pulled the most recent central, I ran the Are We Slim Yet test, I've dumped the about memory reports, and now I'm using load and diff in about memory to examine what's being consumed. And so 8 megs about, 3 megs are just the active about new tab window and some JavaScript stuff. Like this compartment, there's like a meg's worth of JS classes and the required infrastructure there. Some like the actual DOM stuff to set up the page is loaded. All this sort of like JS stuff. some strings. And then there's also, about blank is also being loaded. Like, so when the test ends, it closes all of the other tabs and loads about blank in that first tab. What's interesting is that looking at the original about memory reports, with the most recent uh, Mozilla Central, is that there isn't like a spare content process sticking around. There's still just one content process at the very end, loaded at about blank. That's fine. It's just that the content process is now kind of it's got the about new tab loaded in it as well. What's kind of interesting is that or moving the about new tab loading from the parent to the child has a huge number of benefits for performance. One of the problems is that it requires us to reload a bunch of stuff in the content process that's already loaded and cached in the parent. Things like, I don't know, basically the infrastructure to set up a page. If we were just loading about blank, there's not a whole lot that needs to be like constructed to show just about blank. And that's why, like, if we look at the about memory report of the good case, and we look at the content process, the content process is really not that big. It's spending like, there's 23 megs worth of explicit allocation, and most of it's just like nothing. How am I able to determine it's nothing? Well, I don't see any pages associated with it. That's why. Like, there's nothing loaded in it. It's just kind of like hanging out and waiting, as far as I can see. Marionette is consuming some memory. That's just like test artifact. But it just kind of hangs out. 23.31 megs. And in the bad case, it's the content process is 31.18. That's the difference. And that increase is apparently mainly coming from this new tab, all this JS stuff, heap overhead. So I'm trying to figure out if there's anything actionable or new here. Glyph, all these SVG glyphs, they're taking a little bit, not too much. Yeah, that's kind of small potatoes. Decommitted arenas. Bunch of event listeners there. Blob URL. A blob URL, and this has not been freed. Just a heads up, blob URLs are great, except that when you create them, you have to explicitly revoke the URLs if you're done with it. Otherwise, we cannot clear out images or the stuff associated with it. So whatever, if you create a blob URL, it's worth making sure that you're also destroying or revoking those blob URLs when you're done with them, with revoke object URL. That's a thing. I'm not sure if that's the problem here, but maybe I should ask about that. Blob URL business. And there's just the loading of the about new tab service. The observer service, the preference service, some window objects. The main process doesn't have too much in the way of, there's a little bit of an increase here as well in the main process. I wonder what it is. In heap overhead, in just bin unused. I don't know what that means. Unused bytes due to fragmentation in the bins. So There's just a little more fragmentation. Not really much we can do about that. There's like the 0.8. I don't think we use blob URLs, but we do have data URIs, says Kate Hudson from the activity stream team. What is this? What even is this thing? Okay. Activity stream. Let's just do a quick check. How do you get a blob URL? I'm just trying to remember. Whoops, that's not what I meant to do. Get blob URL. Create object URL is what it's called. Create object URL inside activity stream. Nothing. Not there. The main process has feeds that wake up and run every so often, says Demos. Huh. So that's weird then. Like, so that's the first mystery then, in my mind, is what is this? Because About New tab owns it. Unless, for some reason, is it possible that... hold up. This would be crazy. But, create blob URL. New tab. No? I was wondering if maybe, like, somehow the old new tab was running as well. Had run and hadn't cleaned itself up. Is there anything inside browser that creates blob URLs? Or I've got the name wrong. It's create object URL. Sorry, create object URL, and then in activity stream. No. How about new tab? No. How about browser? Perhaps some other infrastructure creates it on behalf of About New tab. Possible, yes. That's true. Canvas 2 blob URL. If the context menu asks for it. Search uses blobs. Search uses blobs. We use the same as old new tab. Search uses blobs. So content search UI. Converts favicon array buffer into a data URI. Right here, we create a... Is this ever revoked? We attempt to. Whenever an image is loaded with a particular object URI. Default engine. Content search. Create blob. Or create object URL. I'm not saying that this is like where the leak is. I do think there is something that's hanging around that shouldn't be. We embed the search code in activity stream. I'm guessing you're talking about content search UI. Get favicon URI from buffer. Let's just see how that works. That's whenever we are getting the probably these things. These things would be my guess. These icons for search. There's an icon buffer. Icon buffer. Icon buffer. What is the icon buffer used for? Content search uses it. Array buffer from data URI. So the messages named outbound messages. Where does this run? Content search .jsm is run inside the parent process. Okay, so this is going to receive, I guess an icon buffer is, what's it going to be? Icon buffer get favicon URI from buffer. What's the icon buffer going to be? Icon buffer is get icon URL by size. It's a URL. Turns a string with the URL to the engine's icon matching both width and height. So we get this URL. And then content search says, okay, well, given that URL, get me the favicon URI. What? Buffer. Because that's what we're using to display the favicons. Okay. We do that when we either set the default engine. Now what if the image is never loaded? That icon, what do we do with icon? Icon is this. Then we set the default engine to be that. If we never display the image, because I see that we revoke the URI here when we set the default engine. With the current one, I don't think that's what's happening. Here, when the image is loaded inside the one-off buttons, as soon as the image is loaded, that's when we revoke the object URL. But if the image is never loaded, then the object URL, like if we never show the panel, and when is this set up? When is set up one-off buttons is done whenever we receive a message about search suggestions, which I'm imagining would never happen. So if the default engine is being set, if anything ever sets the default engine, and we never show the one-off buttons, we leak these blobs, these favicon blobs. So that's one thing. I think that's true. Is there an unload handler? Yikes, there is a before unload. I think this actually got removed recently. But is there an unload? Because if there was, what I'd do is I would... So here's a bug. I'm going to start taking some notes here. I'm going to call this, well, there's an associated bug. It's this one. So I'm going to put this in my notes. I'm going to say first finding, or findings. Let me pump up the font here. Findings. Content search UI probably leaks blob URLs, blob URIs. If the favicon for the one-off buttons are never shown, i.e. if the default engine is set, but the user never tries to do a search in About New tab. Okay, so that's one thing. Potential resolution. So I'm going to call this leaking blob URI. No, I don't want you to turn that into a number. Stop it. 1. Resolution. Possible resolution. Keep track of the blob URIs that are created in content search UI.js and on unload And on revocation, I should spell correctly, revocation, remove from the list. Create in a list, I should say. In a list on revocation, remove from the list. On unload, if there are any remaining blob URIs. Oh, but about new tab won't be unloaded. It's going to stick around because it's preloaded and sticking around the background. Because you don't leak a blob URI if the owning DOM window goes away. Okay, here's another thing that we could do. Before I continue, I want to try a test in the background. I've had disabled activity stream in that last test. I'm going to do a couple things. First of all, I want to get the numbers, the sort of gross perf herder JSON blob here. That's in the good case. So good case, here's the blob. Then below I'm going to put the bad case. And I got to find where I put it. There it is. This is the bad case. Let's see if we can find the parts that are useful in all of this mess. I'm going to copy the JSON. And I believe I saw a really cool script that Mardak had written in the... He's like, take the JSON and then pipe it through JSON PP. Do I even have that? JSON PP. I do! It's Perl! Okay. So I'm going to say... which one did I just copy? Good case. I'm going to say good case .json. Dump that in there. And then I'm going to do JSON PP. JSON, what is it? Underscore opt. Canonical pretty. And then good case. Huh? Huh? Did I do that wrong? You gotta pipe it. Oh, do I have to like... Good case pretty? JSON? Did I do that wrong? You gotta pipe it in? I gotta cat into it. Oh, that's what I gotta do. Cat. Good case. And then pipe into it. I feel like I'm banging rocks together. Okay. Good, no such file or directory. Cat goodcase.json. Sorry. Valid character on offset for 742. Ah. I don't know what I'm doing here. Okay, you know what? I'm not gonna get distracted. What I would rather do is find the number that I care about. And the one I care about is tabs closed. Yeah, force GC. This is the one. Name, units, lower is better is true, and here's the value. That's the value I care about. That one. It's the shell. It's the shell instead of cat. Gotta try and remember how to do this. Like this, like good case.json. That's not right. Cat. I don't know what you're talking about, Demos. I'm really bad at Bash. Sorry. But I found the number I care about. And it's this one. I'm going to just kind of summarize. Presumably that's bytes. I'm going to convert that into human readable. Bytes is megabytes. And then, oh, where's better? Tab close, 30 seconds, force GC value. That one. And that is 302 megabytes. So, yeah, there we go. We've got our regression. What I wanted to do before we continue, I wanted to try this thing where I keep activity stream enabled, but I disable new tab preloading. Because I don't think that was tried. I know that Mardak was doing some experiments, but I don't think he tried this one. Okay, while we're doing that, while we're building, let's take a look at the memory report again. So that's interesting, but I don't know what to do about it because the blob is going to stick around until we show the favicon or until the tab closes. Maybe there's a way we could delay that, I'm not sure. Delay setting the engine or until made visible. All this JS structure has been created, and that's taking up memory. Okay, let me run the test now. Boop, 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 boop. In one iteration, I do it. Still looking. It looks like it's just the cost of all of the infrastructure to build the About New tab page, and because it's in a content process, it's like it's much fatter than just the old About Blank content process that was so much thinner. Because it's got two things in it now, About New tab and About Blank. Whereas before, About New tab was loaded in the parent process, but I suspect that all of the stuff. Oh wow, hold on. Yeah, in the parent process there's like all this Redux stuff. These feeds have been loaded. It's not too much. They're not huge. It's a little bit. But a bunch of stuff also went down. And that's, I would imagine, because that's the stuff that About New tab doesn't need, or was loading that the main process doesn't need whenever it's not there, if that makes any sense. Like, yeah, in the parent process, the About New tab, the infrastructure to load it has gone away. And just loading it in the content process fattens up the content process. Okay, so we're almost done my next test here. Is there anything else worth calling out? Oh, the content process was loading About Blank, but that went down. In the good case, which one is this? I don't remember if this is good or bad. Is this good or bad? Where's the... 119 in the main process and 23.31, and then 30. So this is bad on the left, good. I like to organize things good to bad, good on the left, bad on the right. So that's how I'm gonna keep things organized here. So in good, we have the about blank loaded, and that's it. In bad, we have about blank and about new tab. And there are a lot of event listeners set up in about new tab. Okay, well, while we're waiting, let's take a look at the disabling of preloading. Disable preloading with but keep activity stream in the content process. So tabs closed, force GC. Where is it? Tabs closed, force GC value. Okay, which is quite a bit less. What? No, translate it for me. Bytes and megabytes. 288, which is closer to what we had before. So yeah, it's the. I think this is a. Why is it good loading about blank rather than about new tab? I.e., do we have an apples? So Demos has a question. Demos is asking, why is good loading about blank rather than tiles about new tab? That's because, I mean, good is loading tiles about new tab. It's just doing it in the parent process. It's not down here. It's up here. Where is it? Yeah, right here. And there are 18 event listeners, 2 event targets. There's other stuff. And I would suspect that about new tab, like the loading of all that stuff, we might be recycling or taking advantage of the fact that like some of the infrastructure, like the JavaScript infrastructure, can be reused. Some of the memory or the objects, it's possible that we can reuse some of them when we're loading about new tab in a process that has already got a bunch of stuff loaded in it. Is maybe an idea. I don't know. But it's just the cost of having this about new tab loaded in the content process along with about blank as opposed to just about blank. As opposed to just about blank. So let's look at the difference again. Like about blank suddenly becomes slightly cheaper, but we have this like big ol' about new tab showing up. Bin unused, what is that again? Fragmentation, so there's an increase in fragmentation. In heap overhead. There's an increase in heap unclassified. Memory not classified by a more specific report. Internal fragmentation in the heap allocator caused when the allocator rounds up request sizes. Okay. Demos wonders, is the problem that we're measuring too early in the life of the content process, i.e. before it has a lot of infrastructure stuff already loaded? I think the problem is that this is like not, I suspect, an engineering problem. This is a trade-off, is what I'm starting to narrow in on, or what I'm starting to suspect. The trade-off is between, it's like a classic space-time engineering trade-off. We can consume less space and run in the parent process and recycle and reuse a bunch of stuff that's already allocated and like exists in the process, with the trade-off being that activity stream is running in the parent, and so while it's laying itself out, it can jank the main thread in the parent process, versus about new tab an activity stream runs in the content process, you don't get all of the main thread jank that's possible when it runs in the parent process. It runs in the content process instead. But then you end up allocating a bunch of stuff that before, when you just had about blank loaded in that one content process, you didn't need before. The other thing we could try and do is think about maybe is there a way that we can be smarter about preloading? We know that turning off the preload, like if we get rid of the preloaded about new tab, the problem goes away. That's the other thing. You can have your pre-allocated content process, but preloaded about new tab goes away. And what does that mean? That means that preloading, if preloading goes away, then new tab starts doing this instead, where it takes like it actually has to load the page. And whether that's maybe good or bad, but I wonder if that's better than turning off, like trying to move activity stream into the parent process. I think it is far less drastic to maybe try turning off preloading instead. Unfortunately, that means you get a little bit of a flash because the page renders and we have that flash. Whereas with preloading, um, it's like, bam, it's there because it's already painted. It's already set itself up. Hmm. I wonder if there'd be, so I have a couple of ideas just kind of floating around in my head. That's why I was quiet just now. Finding two. Demo says there's stuff we can do to optimize. Kate's got some React pre-rendering. What is React pre-rendering? About new tab is being loaded in the content. The preloaded about new tab is hanging around in the lone content process at the end of the test. This is where the main balance of the regression is. Just the stuff required to have about new tab be there. That's right, didn't fix the leaks. It did make the leaks better. One Windows 3 or 4. I don't think turn off preload and fix the leaks. But I suppose that's just a separate problem to fix. React pre-renders to HTML ahead of time. Pre-renders to HTML ahead of time. Okay. It would mean we start with a rendered version of ActivityStream in HTML first and attach React later. Right. I mean, you might lose some of the JS overhead then, but you still need to set up all of the infrastructure, all of the like DOM nodes need to be created and allocated, and all of the like Gecko gunk to like make those exist, and the frame tree, etc., needs to all be allocated as well. And you're gonna always lose versus not having loaded it. You're not gonna make it free. That's not possible. But I wonder if there's let's take a look at the way the test works again. we close all of the tabs. Then we navigate to about blank. And then we take a measurement. We wait some amount of time, settle wait time, which is how long? Settle wait time. I think it's like 30 seconds. Yeah, we wait 30 seconds. And then we force a GC, and we take another measurement. One thing I'm thinking of is that we might be able to notice when a full GC has been run and clear out about new tab during that time. Or like if we notice that the browser is attempting to compact memory to like flush caches and like try and reduce its footprint. Oh, I understand. Kate, I know what you're talking about. Okay, an attach React layer. So less flashing because things other than the search bar would take some time. Right. So what you're saying is that means less flashing if we turn preloading off. Okay, got it. I understand. Before we do all of this, we say signal user active. And signal user active. Normal while being driven by thinks the user is inactive the home because user activity is detected by looking at key mouse events. You mean clear out the preloaded browser? Yes, that's what I mean, demos. Like, instead we manually cause some inconsequential activity to make the browser think the user is active. Then when we sleep to allow things to settle, the browser will see the user as becoming inactive and trigger appropriate GCs as would have happened in real use. Like, make it so that the preloaded browser is one of the things to go if we decide we're trying to compact. I wonder if we could do that. Is there... Or are there better schemes for when we preload? Currently, so here's what I know about preloading. Currently we preload about new tab in a Zool browser attached to the window whenever we have finished opening a tab. It's like one of the first things we do after we open a tab is we create the preloaded browser. And this test is opening tabs by clicking on the new tab button. And that's definitely going to do it. I can see it's doing that right here. It finds the new tab button and it clicks it. Is it rational to make the argument that having this run the content process is worth that cost? I think it is. But I don't think it's my call. That content process is going to eventually, yes, yes, probably with consultation with ERAM. Let me preload about a new tab in a browser. Zool browser attach the window whenever we have finished opening a tab. The whole idea is that we want to predict when the user is likely going to want to see about new tab and make sure and have it ready and painted ASAP. We click the button and then we navigate. Now there's a limited number of tabs that we open as well. At the very beginning we open new tabs, and then we like click on, or we load a URL, and then eventually we've opened like some max number of tabs, and we loop around, go back to the beginning, and go through each one again. I mean, that means that so there are a number of consequences, some consequences to preloading about new tab this way. One, it's likely if the user has a set of tabs and doesn't open a new tab after a while, then the preloaded one might be out of date unless we're keeping the background one up to date somehow. It means we consume that memory either in the parent or the content process. It means that we're preloading when it's possible the user isn't ever going to want to see about new tab. Possible user is never going to see about new tab because, like, I guess that's kind of related to 1 and 2, or it's related to 1 because if they have a set of tabs and it's just like, I'm never going to open another tab in this session, then we've got this preloaded browser just kind of sitting in the background. That's a solid argument, Mardak. Also solid demos. Means that we're preloading when it's possible the user is never going to see about new tab. So, like, is there a better time to open about new tab or preload about new tab? Perhaps if we see the user hit the control button or hover the mouse over the new tab button or menu item, don't we have data that some large number of users on Windows don't use tabs at all? My knowledge on that front is probably out of date and busted. Last I heard, it was like an average of 3 tabs. But I suspect the data that was imperfect. Is there a better time to preload the About New tab? Is there a good time to throw out the preloaded About New tab? Perhaps after some timeout where the user hasn't actually needed it. This feels like a familiar problem. One of the things this feels like is the decoder shutdown issue. So we have this thing where we shut down video decoding but keep audio decoding working after some time of a tab running in the background. This means that when we select the tab, sometimes there's a delay in getting the video to play properly for some large number of milliseconds, which isn't a great user experience. The media team is trying to work around this by sending a signal to start video decoding again when the user hovers the tab. And that's what makes me think of this. Better times to preload about new tab. The hard one would be well, would it be hard? It's necessary, I think, or I would suspect that it is common whenever you use the keyboard shortcut to open a new tab that you hit Command, on OS X anyways, you hit Command first and then T. Very few people, I would imagine, are going to hit both at the exact same time. Because that's imperfect. I mean, that kind of works. That didn't work. That did. That did. That did. That didn't. So I would suspect, and maybe UX has some input on this, that it's oftentimes they hit Command first and then T. And maybe that amount of time, that lag time, if we like notice whenever there's, there are a bunch of different ways new tabs get open, like 8 or 9. Absolutely, that is true. There are a bunch of ways that tabs get opened. Demos says 8 or 9. I agree. But if we, in the same way that we do speculative connection for Neko, and speculative connection is like, we notice that you're typing in the URL bar and we auto-completed to facebook.com and you're like, or Google, I don't know, some website.com, and you're continuing to type with that auto-completion, then we know, okay, you're probably going to go to google.com or that website, whatever it is. We speculatively connect. We warm up the socket and connect to Google in the background. So I wonder if we could do the same thing. We add some kind of like preloaded about new tab, speculative preloader, and you can say like about new tab preloader, like warm up, or like trigger, or whatever you want to call it. And then about new tab preloader, you do that for like, what would you do it for? You do it for control/command hit only trigger, and then maybe a reason. Hovering about new tab button, hovering new tab menu item. Demos thinks that it's a good thread to pursue, but there's a more immediate question. Yes, you're right. I'm getting distracted. I'm trying to solve. You're right. You're right. What are we going to do for 56? I think it's time to lawyer up. Or rather, let's get our arguments together. Let's argue. Let's attempt to assemble the argument that preloading the About New tab in the content process is useful and worth the memory overhead. That's the argument. Classic hamburger or essay exercise now. We have to back this up. Why? Why is this useful and worth the memory overhead? Well, we know that running about new tab in the parent process can cause jank. Even just the I think there are profiles where we've seen that occur. Preload, bug, preload. Is there a bug on that? New tab, a test for new tab, no load event, new talent, new tab. New tab is not preload after browser launch. Kick off preloading at a better time. Let's look at this one. Let's also take a look at uh, when preloading was actually introduced, because I actually remember that. When was that introduced? I think I remember that. That was like way back in the day. 2013. Yeah, back when I just moved on to the Firefox team. Show resolved. Preload new tab pages in the background, swap them. And then look at all these. Analyze cycle collection logs after test runs to detect leaks. Describe, bring back, shut down leak detector. There might be an old argument that we could reuse. Navistyles on Twitch wants to know what I'm doing. Good question. I'm trying to explain away a memory regression with my good friends on the activity stream team. So adds away. Use that testing the runtime leak detection. And then this was added. Preload. Push to try to guess minutes. We'll see if this produces the same results. We're just blaming test creates a new tab. We want to go disable tests. So I'll get it. Well, there's only one intermittent leak. Analyze cycle to detect leak windows. So just missing. He only mentions it once. I don't think there's an argument in here. Let's keep going. Fix remaining. I think this was just about leaks, not about memory regressions. Leak. There was another bug here. Be more intelligent about when to start preloading new tab pages. Holding reference to the idle service in the window. Weak reference. Kung Fu. Initialization task. Serves multiple windows. Was there like a regression? TP5 regressions from new tab preloading. Regression, a 6.81% increase from what to what? From what? TP5 optimized. There's a memory regression, the trace malloc are indeed investigated in respect now expect. There's a regression in TP5 and SVG opacity. Extra pain once the browser's been loaded in the hidden window. Trying to find if there was ever an old argument that was introduced or that was used whenever we first introduced preloading that we can accept the main RSS and P bytes, the 2%. That's expected. There's another page of memory sitting in the background. Here it is. It's expected that there's a regression here. It can cause jank. When new tab preloading was first introduced, the memory hit from having an extra about new tab sitting in the background was acceptable. Deemed acceptable. We know that running about new tab, the parent process, can cause jank, no question. We know that running about new tab in the content process reduces the potential for jank, no question. We know that preloading about new tab allows us to avoid the flash allows us to make new tab immediately useful on demand. We also know that when that About New tab is displayed, another About New tab is going to be loaded up in the background for another content process. For probably a new content process, unless we've already hit our process count threshold. So we've just, it's like investing in the future. The memory the memory being spent here in the content process is an investment. Once the new tab is displayed and goes somewhere, that memory is then freed and can be used by whatever page we're navigating to. So we're preempting. This is the cost of preempting and caching. It's just costing more in the content process because loading About New tab in the content process, having About New tab loaded in the content process is strictly more expensive than loading About Blank in the content process. About New tab and all of its gecko requirements. Strictly more expensive than loading About Blank in the content process, which is what happens when About New tab preloading is disabled. I suspect with the above facts, we need to approach product team, or perhaps MOSIP to make a call here in conjunction with ERAM. My argument, I argue that the cost of preempting and preloading About New tab is worth it for the improved user experience of loading About New tab swiftly. Also of note, there's another fact. There's another fact that we need to look at. Another fact, folks. It is this one. Should be avoid the preloading. The fix to load About New tab in an existing content process should avoid the preloaded content process, right? There is no preloaded content process after the patch you landed. Well, hang on, that's not true. So hang on, there's always confusion between the pre-allocated content process and the preloaded About New tab. The fix to load About New tab in an existing content process should avoid the preloaded content process, right? What's interesting is that well, when I run the test locally on my Linux machine, I open enough tabs such that when the test finishes and the tabs all close, the About New tab is loaded, happens to be running in the same process as the first tab, which is loaded at About Blank, which simulates the situation you're describing, both tabs loaded in the same content process, and there's still a regression. The cost of having loaded that about new tab, I would imagine the regression is lessened though, because you don't have the full-blown content process overhead. The thing I wanted to point at was, what was it? It was resident memory after the tabs are all open and after we force GC. That's here. Look. Like, we've got a bunch of tabs open and we've got a preloaded about new tab. Hold on. Yeah, there's an argument here. In the test that I'm running on beast mode, I only use 4 entries. So the browser process starts up. I open a tab, or I load something in that first tab. I open another tab, I load something there. I've got 2 content processes, and then a third, like after I open that second tab, the preloaded content process is created because of the preloaded about new tab. But then I use it immediately, and then I've got 3 tabs, and then a preloaded content process is created for the preloaded about new tab, and then I use that one immediately. So now I've got my max content processes being used, is what happens. And then I preload the next about new tab, but it probably goes back, that's what happens, it goes back to the first content process because we've reached our DOM IPC process count limit. So notice that the memory usage after we've loaded all of the tabs in force GC has not really changed. There's no regression here. Then we close the rest of the tabs. There's still a preloaded about new tab sticking around, but it's loaded in the same content process as the first tab. That's what's going on. Then in the case for running it in automation, we're running more than 4 entries. We're probably running, I don't even know how many entries. How many entries? What was it? The number of tabs. Max tabs. Max tabs. Max tabs is 30. 30 divided by 4. Right. Basic math. 420. You can't divide 30 into 4. Right? It's that you can't do that. 30 divided by 4 is not an even number, or is not an integer. So that means that we've got like this leftover, which means that we end up having 2 content processes at the end. And that's why we have, when we run this on automation, EricROM has been seeing 2 content processes. And when I run it with 4, I only see 1. But even with the 1 content process, there's the overhead of having loaded it. But there's more here, and that's the thing I want to mention, is that notice that once we hit our process limit, our content process threshold, we do not consume more memory, even though we're still preloading about new tab. And here I'll take a picture. Take a picture, take a picture, take a picture. Nope, wrong. Take a picture. Let me shrink this down a little. Copy to clipboard. We're not consumer memory, even though we're still preloading about new tab. This means that the in the case, like, this means that we're only going to experience regressions in the wild if the user has fewer than the number of fewer tabs than, or I shouldn't say tabs, fewer remote browsers than the DOM process count limit. Right. Experience regressions on while the user has fewer remote browsers limit. If they've exceeded the process count limit, memory usage is not different according to a are we slim yet? And then it's only after we close all of the other tabs and point that initial tab to about blank and take a measurement where we get hit, because we've got that preloaded about new tab probably sitting in a different content process. But you're going to probably use it anyway. You're probably going to use that content process anyway. That's what the pre-allocated content process was supposed to do. So really, complicating the fewer remote browsers calculations that each window can have its own preloaded new tab. That's true. That's true. So fewer remote browsers, not tabs, remote browsers, not tabs. I shouldn't say remote. How about out of process? Okay. So was there no, when we turned on the pre-allocated process manager, was there no regression? Init pre-allocated content process. Pre-allocated. Launching before first paint. No, that wasn't it. Where did Gabor work on this simplified pre-allocated process method? And then use it by default. And then they won't fix this regression. Look, they detected this regression. If I understand the pre-allocated process measure, so this is somewhat expected. Eric Rom says this is somewhat expected. That's what the pre-allocated process was supposed to do in bug 1361808. EROM points, in essence, and as arranged with Gabor, the preloaded about new tab for activity stream replaces the pre-allocated process manager since it will attempt to allocate a new content process during preloading. If we haven't hit our process threshold, points out that it's expected for the pre-allocated process, for a pre-allocated process, to consume more memory. How much more memory? Some expect on the privatized question metric compared to this huge number. On Are We Slim Yet? There was this one. Explicit memory. For B62, highlight that region. What? That's there, right? Yeah, it's right there, B62. So let's zoom in. And then let's add resident memory. Interestingly, resident memory didn't change with the pre-allocated content process. Resident memory after tabs closed. Interesting. Wait a second. Do I have the right thing highlighted? Where am I? May 11th. There was a big spike here. When was this alert? 6453 on May 3rd. Right around in here. Yeah, right there. And look. Slight escalation. And then it went down again. What happened here? Screenshots. Screenshots landed. Why is that related? So this is when pre-allocated got turned on. Why was there no overhead? Why did we not see, like we did see a little bit of an increase in here, but then it dropped over here. I wonder if something else, like this regression existed, but something ate it. Something improved over here. Apparently screenshots. Um, what else could have improved it? No. Hmm. That's expected for a pre-allocated process to consume more memory. So how come we didn't see a similar regression occur for, what was it? Resident memory tabs closed. Tabs closed. When the pre-allocated content process landed. So that's actually something I'm very interested in. So what I can do is I'm going to turn activity stream off and turn the pre-allocated content process manager back on. What's pre-allocated? What bug is this? I have a link. Disable pre-process pre-launch. So we're going to turn it back on. DOM IPC. That's in app profile firefox.js. Turn it on. I hope this is helpful. I hope I'm not just wasting everyone's time. I feel like talking through this though is helpful. Um, I think it's important that we answer this last question. I want to know if there is what I'm going to do is I'm going to run Are We Slim Yet test again with the same number of tabs, but with preloading on and activity stream off. And what I'm hoping to see is that there's a content process hanging around, two content processes hanging around. So I think we should see. Is that true? 1, 2, 3, 4. Close. No, hang on. I'm going to do 5 entities. That way, 1, 2, 3. We create 1, 2, 3, 4. Then we close all the tabs. And we close all the tabs. So we're going to do 4. 1, 2, 3, 4. We've reached our max content process limit. When we close all the tabs and we hang around, I feel like we should probably then allocate a pre-allocated content, like create a pre-allocated content process after we've closed all those tabs, because we've closed, like how does that work? Pre-allocated process pre-launch enabled. Like, when does it do it? There's an observer. Take, enable. Observe when we observe a process shutting down. Observe process shut down. If we reach the max process count reached after we've changed the pref, take, then we allocate on idle. And that's something that should occur, I think. Allocate on idle. Allocate on idle. Okay, now. Allocate after delay. Pre-allocate process. Blockers. We'll retry later. Okay, let's see. Because if there is no content process there, I wonder if we can then copy the same scheme. Like maybe the pre-allocation in the content of the pre-allocated process manager is like blocking the pre-allocation in certain states. Blockers. What is M blockers? Add a blocker. Why would you add a blocker? Why would you add a blocker? Can be reused. Because you're... And why would you remove a blocker? The content child goes idle. It sends us a first idle message, which we use as a good time to signal the pre-allocated process manager that can start allocating processes from now on. Content child goes idle. Huh. So you'd think after the tabs have all closed and it's just sitting there, we'll have pre-allocated another one. But maybe not, and maybe that's useful. Allocate now, allocate after delay. It says allocate after delay. Remove blocker, allocate now. Remove blocker. So there are things that can block pre-allocating the content process. I wonder if there are things that should block preload and pre-allocating about new tab. Okay. So this is with the pre-allocated content with pre-allocated content process enabled, activity stream disabled. Paste. Tabs closed, force GC, value that. That's the value, and converting that into bytes, I can already tell that's quite low. Bytes. $277. Bad case. Good case. Interesting. lower than the good case. I don't know what the noise is. I'm only doing one iteration, and this test might be really noisy. I don't know. But let's take a look at the memory report. We're going to call it pre-allocated. There is a content process sticking around. Is it just one? There's just one. That's interesting. There's only one. Aha! Interesting. After we close all of the tabs and load about blank in the initial tab, we don't seem to pre-allocate a content process. Why not? What's the delay? After delay. Delay MS. Doesn't look like there is a value, so we do the default, which is after 1,000, so about a second. Okay. Oh. The intention is to put off launching another app process until the last one has finished loading its content. Because we loaded about blank, do we decide that it's not, like, that's not good enough? We're not going to allocate a content process? I wonder if we could use a similar scheme for about new tab. Allocate delay. Time for some good old printf debugging. Allocating after delay called. Allocate after on idle called. Attempting to allocate now. Printf cannot allocate. Cannot allocate content process. Delaying until later. Blockers empty. Blockers is empty. True, false. Printf pre-allocating content process now. Okay. All right. Linking. You might want to use fprintf since it's unbuffered. Oh, good call. Shoot. Bail out. Print F. Yep, 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 yep. Yeah. Thank you, Demos. Whoopsie daisy. Printf. Oh, standard error. I gotta pass standard error. Whoops. How does that work? Fprintf. Fprintf. Where have we done this before? Just to standard error. Is that some constant I can just pass in? Yep. Okay. Sprintf. It's fprintf, yo. Standard error, not sprintf. Okay, so sprintf. We're gonna replace that with fprintf standard error. Come on, build.
Okie dokie.
That's my computer speaking. Do I have standard IO? Oh, we'll see. Oh, yeah, it likes it. And linking. Let's see if during the linking phase it's okay. Hope standard IO's in scope. Come on. Come on.
It's me, Mario.
Come on. Why is this taking so long? Hey, alright, it's done linking. It's gonna work.
Oh yeah. That's right.
Brace yourselves. Alright, here we go. One iteration. Alright. Where is the logging I put in? Standard error. I would expect to have seen it by now. Hmm. Is there like an argument to mock? Yet test. Logging. Package. Non-debug builds, they're muted. How do we get standard error? Oh! Mozlog, possibly, yeah. Okay. Here's the other thing. Maybe I can I could probably just instead of doing the Are We Slim Yet stuff. How about I feel like I could just like mock run. Cannot allocate content process. Why not? Why can't you? Can allocate is true if it's enabled, blockers aren't empty, there is no pre-allocate process, not shut down. Enabled? So this is gonna probably be a bit boring. True, false, printf. Blockers empty? Have enabled. True, false, printf. Existing process? And pre-allocated process. Hopefully that will coerce. True, false, printf. Shutting down? Shut down. True, false, printf. Limit reached? Content parent is max. Max process count reached. Literal string. Default remote type. True. False. Alright. Mock. Build binaries. Maybe that'll be a little bit juicier. Fprintf again? Well, maybe, except that like I'm not running the test anymore. I'm just doing it like normally. Old habits die hard. I'm just like running the browser. And so I'm getting all of the printfs directly to the console. And that's okay. Linking libzool. Now, if this, I think I'm gonna cap the stream off. I've gone like 45 minutes overtime. I probably should do other things, but I think we've got a pretty cogent argument here. I really want to understand this last bit. It's all about whether you care about time sensitivity. Not really. It's true. It's true. Timers and timers. Enabled, true. Blockers empty, yes. There's an existing process, true. Attempting to allocate now. Enabled, true. Blockers empty, true. Existing process, false. Shutting down, false. Limit reached, false. Attempt to allocate now. Oh, so there is a pre-allocated content process now. Okay. So now I'm going to send this to some page. So we should have two content processes. Oh, and now we have another pre-allocated content process. Hang on, let's go to cbc.ca and then homestarrunner.com and then mozilla.org. And now before I launch this next one, let's do that. Why aren't we attempting to allocate content processes anymore? So we reached some kind of maximum. I'm going to shut down, I'm going to close everything except the initial tab. Oh. Gbrowser, close, remove tabs, remove all tabs but gbrowser.selected tab. Yes. And now I'm going to send this one to about blank. And we don't allocate a content process. Notice that this has been silent. I don't know what's triggering it or what we're waiting for, but like we're done allocating content processes now. Oh, now we've done it. So we do that. We do this. Allocating another one. Maybe allocating another one. Maybe allocating another one. Maybe even allocating another one. And then close all but the selected tabs, and we send this tab to about blank. We don't allocate one. Like if I go to about performance, or even just let's see, top, or ps aux Firefox. Oh, whoops, grep. Yeah, only two processes, the main and the content process. So interestingly, that just seems to be easy to reproduce. You consume all content processes, then close all but one tab and send it to about blank, like the AWSY test, and we don't pre-allocate another content process. That's why we slipped under the radar here, or that's why the pre-allocated content process manager slipped under the radar. Okay. What can be easily done to reduce regression even if accepted? Good question. Here, let's look at the diff again. 3 of the 7 megs, so almost half of it is spent with all these like JS classes. Like maybe what you were talking about, what Kate's working on, actually. You have the HTML all kind of like laid out, but you don't attach React till the very end. That might save some memory possibly, because you don't create all of these like JavaScript structures. Possibly. I don't know. Okay, so I'm gonna call it. Hey, thanks so much for watching The Joy of Coding episode 106. I hope that was useful. I hope that was interesting and entertaining. I enjoyed it. If you're interested in following along with this bug that we're hacking on, the arguments we're trying to pose, let me just put a link to that in the in my agenda for today, and then the folks who are watching, you can follow along in this bug. There's also an GitHub issue that oh shoot, hang on, active. This is the name of the bug. Gonna put that in here. I'm going to copy the link to the bug. Now I'm going to do this. And then my notes go here. Sorry, I'm just going to do a little bookkeeping. My notes, copy public link. And that goes here. Okay, there you go. And then the GitHub issue. Real quick, the GitHub issue is here. And that's it. Okay, thanks so much for watching. I hope you enjoyed the episode, and I will see you, hopefully, whoops, I will hopefully see you next week. Take care. Bye-bye.
The joy of coding.
See ya.